Jax will give me a signal when the live stream is up, and I will begin our introduction. Okay, hello everyone. Welcome to Concordia University's fourth space. And welcome to the next installment of our Closer Look series, where we look behind closed doors and spaces into projects you might not know about at Concordia. And today we're taking a closer look at the Howarth Lab. But just to help situate you first, we are streaming to YouTube live from Concordia University, and we are located on unceded Indigenous lands in Tiohtià:ke, Montreal. Here at Force-Space, we work with our university community to help mobilize knowledge, co-create daily activities, examine research questions, projects, things happening across the university. We're also hosting this as a live stream event from here, but we're also on location. So just let you know, things can happen. We may have video and connectivity issues. That's to be expected. But please stick around with us as we show you around. We're also running this event as a live stream Zoom meeting. So anyone joining us via Zoom or here in the space, if you have any comments or questions, just raise your hand or add them into the chat, and we'll try to get those into the conversation as well. Okay. It's now my pleasure to introduce the Coordinator of Sustainability and Research, the Office of Research, Brett Cox, to tell us a little bit more about the Sustainable Research Practices Project that kind of helped shape some of the things happening at the lab, which we're going to go to in a second. But I'm just going to pass it over to Brett to kind of give us a bit of context for that. Hey, Brett, welcome.
Thank you so much, Doug. You can hear me? Folks can hear me okay? Yes? Hello, hello. Thank you for having me in this space for Concordia community. Hello. Hi, Clara. So good to see you. Wow. Yes. Okay. So this project, Sustainable Research Practices in the Lab, originated from the Concordia Sustainability Research Action Plan. And under that action plan, there were several different targets and strategies brainstormed, created with the intention of making the university and its operations more sustainable, of course, specifically in the research area for my portfolio. And one of those projects was creating sustainable research in practice guidelines. And that can look like a myriad of different things depending on the research context that you're working in. And with that and the funding that I had, I decided to start in the lab, feeling that that was it felt like the most accessible place to start in terms of materially reducing any negative environmental impact or otherwise. It's proven to be a very complicated project, but in a good way. It's just, all the different contexts, all the different research endeavors, trying to make them more sustainable is always a fun journey, fun adventure. So this is where the project originated from. I mean, looking into it further, while the work that's done in labs is, does incredible things across all different research areas, the waste, whether that's environmental or otherwise, that's created is also hugely impactful, often in negative ways. So this project is quite significant. There's many other universities across Canada and across the world are already engaging in this type of work as well. So yeah, there's a lot of inspiration out there, but we wanted Concordia-specific examples to be able to refer to and draw from when we were putting together a guideline for these practices to say this, we have these concrete examples at Concordia, this is what it looks like, this can be done here. So with that, we went ahead and hired 3 students, Clara being one of them. And it was really a pleasure to get to work with you, Clara, and learn from you and see this journey grow. So with that, I'll pass it off to Clara, yeah?
Yeah, let's pass it off to Clara. Let me introduce you. Clara, you're a PhD candidate in the Department of Chemistry and Biochemistry, and you're going to show us around the Howarth Lab today. Clara, where are we? What building are we in?
Hello. So we are in the Hub building at the Loyla campus, and we're gonna walk through a lab today. It's a shared space, but I can show you the Howarth Lab here.
That's great. Thank you. Let's go. Team Force-Space, taking us through.
So Isa will give us a little overview of the lab.
Okay.
And take a look.
Just
Get all
see
your
how
questions
things are
ready.
laid out. It's just great just to be able to see what the spaces are like, what kind of things that are happening just on a wintry day here.
As you can see, a lot of chemicals. We'll learn all about those.
You got a view outside there. Okay, now we know. Hi, Clara.
Hey, so let me talk to you about what we do here.
Yes.
The Howarth group, we are focused in synthesize MOFs. MOFs are metal organic frameworks. Here I can show you a model what a MOF is. So we have here the structure, just an example. MOFs are composed by metals. Here, these are the metal nodes of the material, coordinated by organic linkers that we can see here in between the nodes. So essentially, you have infinite combinations between organic molecules that you can use in different metals that you can use to synthesize MOFs. MOFs are very interesting for many applications. Here in our lab, we work with not only synthesizing new materials like new MOFs, but also trying to apply these new materials to sustainable applications. So we have people working in biodiesel synthesis. We have people working with detoxification of welfare agents. We have people working with carbon capture, for example. And why MOFs are good for that? So you can see by the model that we have a bunch of empty space on the structure. So we have a really high surface areas for this type of material that we can use, for example, to absorb whatever you want inside the pores. The important thing is that it should fit, so depends on the size of the pore, but you can put almost anything inside the MOF. And also you can use, as I said, for catalysis, because in these materials, we often have open metal sites. So you have the metal nodes coordinated by the linker, but you can also have metal that is free to act as a catalyst in different reactions. I feel that these are the two main points about MOFs.
Clara?
And, sorry?
I just wanted to see if I was following along correctly. So the lab, you're kind of doing two things. You're developing the metal organic frameworks themselves, those molecular structures. There are different types of those, but then also how they can be used and how those can be used in sustainable practices, but also other methods. Is that kind of the two kind of approaches? Okay.
Yeah, exactly that. And we are thinking about the sustainability not only in the application, but we often try to be more sustainable regarding the synthesis itself of these materials.
The making of them, okay.
And that's what essentially we talked about in the project with Brett. So here I'm going to show just some examples that we can use to make more sustainable reaction in this sense. Okay. So let me explain you. I'm going to show you after exactly what we do. But first, how you make a MOF. You just essentially you mix a metal with organic compound. So here we have a bunch of options.
Right. Some ingredients.
Yeah, exactly. It is a recipe that we are following. In our lab, we often say that we are cooking MOFs because of that. And to have a good product, as any recipe that we are following, you have to measure everything that you're putting in the reaction, right? So I remember that Sarah already talked about a little bit about that, but here we have two ways to measure. So we can use the weighting paper. Here I already have an example.
And what are we measuring today?
So I'm gonna show you an example because it's gonna be easier to follow about the process itself. We're gonna synthesize a MOF that is, the name is Cal28. It's a zirconium MOF. So here we have the zirconium salt that we're gonna use. The zirconium salt, I already measured this. And here we have the linker. And something very interesting about this MOF and about this linker is that this is a renewable linker. So the molecule of the linker that we are using as a piece of this puzzle is, so the linker is the molecule that unites the metals here, you see? So specific linker is a linker that you can obtain from biomass. So it's really cool. And I'm gonna show you this MOF is green from the beginning to the end of the synthesis.
Hold on 1 second there, Claire. I think we
Yep.
lost our
We
video
lost you there,
connection.
Team 4Space. Okay. I think we're
Hold
working
on.
again.
I think you can still hear us, but to get
We
video.
can hear you. We'll just hold for a minute. We're learning about linkers. Absorb that. This is the second lab that we visited in this series, that along with the project that Brett that you've been working on. The last one was the Forgione lab, and then I think our next one is the Satcher. That's it, the Satcher lab. And last time, oh, we're back. I'll save my anecdote about what we did last time. We'll get.
All right, here we go.
Okay.
While I'm doing this, Sarah already talked to you about the weighting bowls. It could be a more sustainable way to measure stuff because you can rinse and use again multiple times. And with the weighting paper, we discard that after use. But another thing that is very important, besides like buying new stuff to use, like to replace what we already have, is that we have to think how we do science. It's like we should plan the day before we came to the lab and do everything. Because for this MOF, for example, I was working with this MOF for, I don't know, like 1 year and a half. So I synthesized this MOF many times, and I would synthesize this many times across the day. So what I would do would be just to use the same weighting paper for the same reactant multiple times during the day. So that way I would reduce the waste that I was producing with the weighting part of the synthesis. So now I already measured the zirconium. I'm gonna measure the linker now.
For Space, we've lost our camera view, but we can still hear.
Yep.
Okay.
We'll keep going on this side and working on getting video back.
All right. We can hold for a second. Jax, are you able to bring the audio down a little bit in the space? Brett, how did much different, like how each lab had its own practices already, and then there must have been kind of an evaluation kind of phase where you kind of work with them to, oh, we're back. We'll never get to these anecdotes.
So I measured the linker, and now we're gonna transfer everything to this vial, because this reaction is also microwave synthesis. I forgot to talk about this, but something that is, when you talk about sustainability in chemistry labs, you always gonna find something about green chemistry and the 12 principles that we can follow to make chemistry more greener, I would say. And so one of the ways that we can do that is to reduce energy while we are doing our reactions. The commonest way, I would say, to synthesize MOFs is using pressure reactors. And that's something that we don't do in our lab, also because one of the principles of green chemistry. So because it's safer not to use, don't use in the pressure reactors, and instead we can use these vials here, for example,
Okay.
and just mix everything and cook them off in an oven. Very straightforward. You mix everything and put in the oven. And in the project, we talk about using those instead, because these reaction jars, they do essentially the same thing, but these ones you can rinse and you can use again, while these ones you have to dispose of after the reaction. And when we are talking about synthesizing a new material, a student who can set up like 24 reactions at a time. So it's a lot of glass being wasted here. And another way to synthesize MOFs is microwave synthesis. So I will use this tube here. This one is also something that we can rinse and use again. So it's a synthesis that also reduces the waste, but also reduce the amount of energy. So if you are using this, you're going to spend like 3 days in the oven. The synthesis that we're going to do today in the microwave is only 2 hours. So we are also saving a lot of energy here. So I'm just going to dump everything on the vial. Here we have this metal salt. And now the linker. Here. And now we're gonna go to the fume hood to add the liquid part of the reaction.
So why are we heading to another station to add the liquid?
It's for CEFET. So
Okay,
if you are
safety.
working with liquids, I'm gonna add acid here. It's nothing like too toxic. It's acetic acid, so it's vinegar basically. That's something very nice about the synthesis too. So we need to use the fume hood for that to avoid spills here. So I'm gonna add. Another thing about MOFs is that often you need to use toxic solvents to synthesize. And this MOF, for example, and it's something that we try to work in our lab, is to find new paths to synthesize materials in a way that we don't need to use these toxic solvents. And this MOF is a good example of that. This MOF was not for synthesize here in our lab. It's a published MOF, but it's an example. The synthesis only uses 800 microliters of water. And a little bit of acetic acid. Before we go to the microwave, I just want to talk about another thing that I talked in the report that was, it's also related to the part of planning your stuff before. So I was doing like 10 syntheses of that in a day. And if I use only one tip, this is a tip from the pipette, these are disposable. And I was always pipetting the same stuff. So I was always pipetting acetic acid and water. And what I would do is just, I kept one of those boxes, like empty boxes. I labeled the tip. And I was using the same tip over and over again because I was always using the same reactants. And of course, this depends on the reality of your lab, of the research that we are doing. But like for me, for this MOF specifically, mainly, it's not a problem that I would have a little bit of water in the tip and I would use the tip again, you know? So the synthesis would work just fine. And I was avoiding to throw these, like, I think I probably did this reaction 200 times. So it would be 200 of these for each solvent that I was using, right?
Yeah.
So is that. So you just need to really think through before what you are doing, like, because I feel that it's harder to make stuff more sustainable if you have to buy everything new, right? And we
Yes.
don't have, I don't think that we even want that. But if you can really think about what you're doing and taking small steps that will reduce a little bit of the waste that you are producing, and everyone do that, it's gonna be like the result is gonna be great.
Clara,
And now for
I had a question for you and maybe for Brett also. Did you already, like in the development of kind of what practices you were going to change or be aware of, did you kind of come into the project already knowing that there were some practices in the lab that you could change that could be made more sustainable, or did you really uncover them during this project?
I feel that most of the stuff that we talked about, we kind of already knew, but
You already knew.
sometimes,
Yeah.
yeah, it's just hard to change stuff, like you were already doing like that for so many years, and it's just hard. So when you really take a time to think about that, is when you realize, like, oh man, it's a lot of impact that we are producing here, and we can be better, and not like we also want Concordia to invest on this. Like, Concordia has to be better. I was talking about the building itself before, but also we have to think, we have to take responsibility for our actions, like sometimes we do stuff because it's the easiest way. You need time, you don't have much time, so you just think, I'm gonna do this reaction now, and I'm not gonna take like 15 minutes to think what I am doing, and we can be better just by doing that.
Yeah.
Makes sense?
That makes sense. That makes sense. Yes. Thank you.
All right, I think we're off to our next step at the microwave.
Oh, I
Okay.
just forgot to get something, sorry.
Thanks, Isa.
Let's-
We'll just peek around while Clara's preparing. So I guess Clara mentioned that this is a shared lab, so I can see that there are projects probably happening up and down in different parts of this part of the lab.
Yes, I think Claire was mentioning they have about half of the benches, and then the other half are
Yeah.
shared
For the
space.
Howarth Lab.
We
Okay.
have, I'm good. I just forgot to put the steering bar inside already put. But here we have 4 groups. So this side here, where I was, we have the Howarth Lab and the Mayevsky Lab in the same kind of corner of the lab. And in the other side, we have Dr. Nakasha and Dr. Capobianco groups.
Okay.
And it's also a way to save resource, right? If we are sharing the space, and we also share even chemicals. So if I don't have something in my lab, I don't need to buy just for me to test one time. We check with the other labs, and then we avoid to buy stuff that we're not gonna need after. So here we have the microwave. So it's the same as cooking at home. Like, microwave makes things get hot faster, right? So it's like that. So this synthesis, I would spend like 3 days in, sorry.
We'll look away
Yeah.
for the password. Admin 1234. My microwave's not password protected. Probably should be.
So I'm gonna just choose the method, and we have already method set up here. Let me just show you something. I always talk about that. The method, you're gonna see here the number of times that this method was run in this microwave. So 211 times. Only this microwave that I was performing the same reaction. So imagine if I was using disposable vials and threw away all the tips of the pipettes that I was doing, and all the waiting papers for each time that I did this reaction, that I set up this reaction. So it's a lot. And this is not even counting because we have other microwave there, and I use it there too. So I'm just
That's significant.
And now it's gonna take 2 hours to this MOF be ready
Instead of days.
instead of days. Yes. And this MOF is a cool project because we were synthesizing this MOF. Is a work that we were doing with Dr. Nakash students. So Michelle works with biodiesel production, and we use this MOF to catalyze the synthesis of biodiesel after. So we have a very green MOF being applied to something that application that is also sustainable.
Oh, but I think we lost the visual there for space, but we still have the sound.
Okay, do you want me? I can show, can talk a little bit about the other stuff that we have had been doing.
Sure.
About the report. Let me just walk through the other. We're just gonna go back to my fume hood.
All right. We'll meet you back at the fume hood. But what question I was asking before, Brad, was just in terms of, yeah, I think Clara already kind of specified from her perspective how much everyone knew in advance about, oh, there's many sustainable practices we could bring in, or if it was more of a process of kind of discovering them.
Yeah, I mean, I think it's a bit of both, but the beautiful thing about this type of project is it seems, from what I've learned through the students' experience here, but reading of examples at other universities,
Right.
is so much of the work of making a lab sustainable is so often just communicating, building relationships, and being intentional in their actions. Like, so often the opportunities to be more sustainable are, as Claire mentioned, already exist.
Right.
It's taking the time to tune into them, but I understand that that is difficult. I mean, when students, faculty already have quite busy schedules, it's a lot to add in another thing. But if time, space can be spent, the resources saved can be significant. Like, even as something as Claire mentioned of just sharing resources with other labs,
Right.
especially
Yes.
when you're in the same space too.
Yeah.
So yeah, I did assume
Keeping
that
that conversation going.
exact. So I did assume that there were already a lot of solutions here. It's just digging in and unpacking, finding them.
Giving that opportunity to even like this program and working with Clara to kind of like look at them and give a moment to say, oh, now's the time where we could start doing this thing or do it more. Okay,
Yeah, exactly.
Clara, we're back. We've got you. Hello.
So after we finish with the synthesis for all of MOFs, we have to wash them. And how we do that? We collect the solid that was formed in the vials or in the tubes that I'm gonna take out from the microwave after, and you transfer to these centrifuge tubes, right? And these are disposable. So every time that we are washing a different sample, we are gonna use one of those. And something that here we have someone washing, by the way, some MOFs. So you can select the white powder dispersed on the solvent that they are using to wash. And it needs to be on the centrifuge tubes because then we use the centrifuge to collect the solvent, to remove the solvent and get only the material, the solid itself. And something that we talked about in the project was to substitute the plastic tubes, the disposable tubes, for glass tubes that we can wash and reuse again. That's something that we talked about. So we have different sizes. So this one is the 50 ml one. And we also have an option with 15 ml. And
Okay.
I was talking, I was writing about this, and Sarah also talked about that in her tour, is about if you are washing more stuff, we are also producing more liquid waste, right? So
Right,
it's
yes.
a math that we need to do to see what is worth or not. So here, just an example, here's my liquid waste. In our lab, everyone has a liquid waste bottle in the fume hood. And something that is we come out like, because when you are washing stuff, more than that, if we have to wash more, we're going to spend more water washing too, right? Mainly because in our lab, everyone is responsible for their own glassware. So I would finish my day and I would wash everything that I use. And I don't know, like each one of us can be like 5 beakers, 5 graduated cylinders to wash. And if we had like on the facilities, if the facilities think for that, and each lab has washers. So if you use like automation to wash the stuff that you're using, and then as you do in your house, right? Like we wait till the washer be full of glassware, and then you wash them. So we would reduce a lot of the water that we are spending more, because now we are using glass centrifuge tubes or glass vials instead of the disposable ones. So something that we talked about, not only about our actions, but also the buildings, they have to be thinking for that. Like it's something that it must be in the planning of how we're gonna build our facilities.
At the level of the lab, imagining how the lab itself works and providing for that. I can see that. Okay, thank you for that, Clara. I'd actually just wanted to see, Brad, I don't know if you had any other questions or for Clara.
Well, the only thing I was wondering is, I mean, you were given a small budget to purchase any equipment to test out. Were there any pieces of equipment that you purchased that you didn't speak today that you were particularly excited about that you wanted to show us?
I didn't talk about, because Sarah already talked about that, is the condensers, like the water-free condensers. So we had the same idea as the Forgeon lab is using, is similar idea. But I don't have right now, because not all in Sarah's lab is more important the condensers. For our lab, not all of us uses, but is the I can show you the setup if you want.
That's okay.
Yes, please.
I mean, if you have it nearby, but it's not.
Oh, we have just an example.
Let's try it.
So Sarah talked about the condensers here, right?
Yes.
Turn on the light.
Aha.
So so you have these connected to the water system, and you need a constant flow of water in these systems to cool down the reaction that you are doing. And something that you can use is the waterless condensers. So Sarah showed the one with ethylene glycol, I think, and we have the one. Let me just see if it's here. This one here.
Whoa.
So the example of Sarah was that you fill the condenser with the liquid that is going to help to cool down your reaction. This one is one that works with the air. So you don't need to add anything here. You just clip on the back of the fume hood, and then here is going to be the balloon that you're going to do your reaction. And this setup here helps whatever you are doing to cool down just with the air.
It looks like a humidifier, like the.
Yeah, it's aluminum.
Aluminum?
Yeah.
Okay. Oh, yeah, it is.
It's very heavy. You can.
Oh, yeah.
It's very heavy. So, but the difference, I think, that's why sustainability sometimes is not going to apply for all like the measure that we are taking is not going to apply to all labs, right? So in our case, this works a little better because we don't need that often. So we wouldn't have to buy many of these because these ones are expensive. Like they are really, really expensive. So if you are talking about a lab that you have 10 different systems of condensers, it's going to be expensive to substitute all of that. In our case, works because we have only one or two people that works with this. And if you are talking about like teaching spaces, it's not really worth to buy this one I think, like, because it's expensive. So the other option that Sarah presented would work better because you can adapt whatever you already have. And since we are talking about those, because something that this come up with the during the project, we have someone from facilities visiting the lab, and they were talking about how this could be fixed, like the waste of the water on the condensers, just by if they had during the building construction, just to set up, because we have already a closed system of the water in the building, and you could just set up this on all fume hoods. So the water recirculate on the building all the time, and we wouldn't expend that much of water to do
Building the
reaction.
closed water system right into the building, into the lab itself, instead of an adding. That makes sense.
Yeah.
Clara, thank you so much for showing us around today. Brett, I don't know if you had any final observations, comments.
I don't know.
It's
Just yeah, thank you as well for space, and thank you so much, Clara, for your time and showing us around. This was really interesting.
Yeah, I feel like the conversation is really just beginning around this, and for at least from our perspective, seeing inside these labs and seeing the sustainable practices that are being kind of developed in that conversation is really great. I really appreciate your time, Clara. We're going to be closing up the Zoom and the live stream now, but just want to note that this conversation remains available on our YouTube channel, and you should revisit it, and you should share it, and you should also have a wonderful afternoon. Bye-bye. Thanks, Brett.